Hello students, again we are back on from Minervaa Adventure. Mock test for you is giving us an opportunity to interact with you though online virtually. So from NEET 2021 we are running the classes and you are enjoying it, and you can see that here as per the chapter lesson plan you have we are going for the very important part of this motion kinematics chapter, that is a graphical analysis. That is so important to us, that graphical analysis. Now first of all, if we want to have this graphical analysis, we know the various types of, basically the various types of graph we use in mathematics connection in this particular chapter of physics, that is motion. So if we think about the straight lines first, which is so important to us, that straight lines if we think about. So there are different formats of straight lines we have. So let's have x and y. This is the origin. This is x dashed and y dashed. So if we draw different types of straight line for this kind of two-dimensional approach, so automatically this type of straight lines will have an equation, that is y equals to mx when it is rising, that y with respect to x, and this is falling, the rate of change is y equals to minus mx. We know that m is called tan theta, which is called the slope of the graph or slope of the straight line, and if the slope is constant, then the graph nature has to be a straight line. It is not changing. But if the slope nature is variable, then definitely it's a curve, the graph you are plotting. So remember, the slope is always, it can be given by dy dx also in terms of calculus when it is y is changing with x. That is, suppose in a graph, this is the nature of the graph. So this is theta with the angle made with the positive x-axis. So here also at any point this will be corresponding angle theta. So at any point, if this one is delta x and this one is delta y and delta x is tends to 0, so then the slope tan theta, that is m, that is actually delta y by delta x, and if this delta x limit of delta x tends to 0, we all know this delta y by delta x will be dy dx. So dy dx is also represented as the slope of a graph, obviously the xy graph, and if the slope is constant, if the dy dx is giving you a constant, yielding a constant value, then the slope is obviously of a straight line. Now it is y equals to mx we got, y equals to minus mx we got. Now we know there is another format of the straight line that is oftenly known as y equal to mx plus c, where c is the plus c is the positive y-axis intercept. The same c, if it is cut here, it is minus c, then what will be this nature? So this will be simply y equals to minus mx minus c. Again, if we draw from here, what will be the nature of this equation? This is y equals to minus mx, obviously it is falling down, but it is plus c. So y equals to minus mx plus c definitely. And when it is rising up, it has to be mx, which is positive, but it is definitely rising from a negative c. So y equals to, it should be mx minus c, and you can see all these postures of the straight lines, they are forming like a reflection image diagram. That is a reflection diagram of rays of light. It's so interesting, right? So it is looking like a reflection of light rays that is getting created, and the y-axis is playing the role of a mirror or the reflecting surface. So it's so interesting, the mathematics is, right? Now the thing is, from here we can have also some kind of straight lines which are useful in physics. That is, suppose we draw this kind of representation, which is also an important format in physics. Suppose this is our x and y axis and this is the origin, and if we draw a straight line like this, so suppose at this point it is P and it is Q. So at Q it is intersecting at a point A0, it is intersecting at P, it's 0B. So we know there is an equation that x by A plus y by B equals to 1. it is called the intercept form. So this is very, very important for us that we should remember. And basically the form of a straight line we remember, that is y minus y1 equals to m into x minus x1. So this is very important for plotting any straight line, where m stands for y minus y1 by x minus x1 actually. So you can write it like this. It is actually giving us the concept of dy by dx. So slope is very important, and the different forms of straight lines are also very, very important. Now apart from this straight line, all the nature of the motions can be curvilinear, you know. That's it should be along the curves. So when it is along the curves, there can be open curve, there should be some open ends of the curve, and there can be bounded curves, that is actually is forming some bounded shapes, that's definitely enclosing some area, surface area it is bounding. So these are the things we need to concentrate on. Now I hope the straight lines part is over. Now we are going towards the circle. So if I think about the circle, so we need to start afresh. I hope this you have all noted down and you are following with the next part of the video. So straight line is over and we will apply it in various cases. These equations are enough for our purposes what we are going to use it. Now next thing is circle. So as we know, for circle there are many types of equation. Suppose this is our again that x o x dashed, y o y dashed. So these are the basic equation, basic coordinate system we have. Suppose we have a circle which is having the center at the origin at 0, 0. So for this kind of circle, let's concentrate on a point which is on its circumference, let it be P, and whose coordinate is xy. So this must be x and this must be y. So if we connect this radius, definitely this is r. So r has to be root over x square plus y square. This r has to be root over x square plus y square. Now if I square it from this particular equation, for the circles like this which has center at the origin, its equation will be like x square plus y square. So this is a standard equation where you can have the equation of the circle, which is x square plus y square is always a constant. So remember, how can you identify the equation of a circle? That both x and y will carry same power on either side. Both x and y will carry the same powers on either side. Remember, so from here it is clear for us. Now again, if I go for another format of the circle, where you can have the circle center, it's suppose at a point which is at alpha, beta or anywhere. So when it is at a point alpha and beta, so which is not at the origin at any point, suppose here is the center, so here are the radius we can have. So for this kind of circles we have equation x minus alpha whole square plus y minus beta whole square equals to r square. So when the center of the circle is not at origin, so when the center of the circle is at a point of coordinate alpha beta, so then the equation of the circle will look like x minus alpha whole square plus y minus beta whole square equals to r square. It will be like this only. Now from here, there is a general equation of the circle, we must follow it. This is very, very important. That is x square plus y square plus 2gx plus 2fy plus c equal to 0, where c is a constant, and center of the circle has the coordinate minus g minus f. That must have the coordinate minus g and minus f. So from here what I can actually concentrate from this particular point, that when the center of the circle is at minus g and minus f, we know. Now from this idea we can have the radius of this auction like this, that root over g square plus f square minus c. root over g square plus f square minus c will be the radius formula when I am using this particular equation of the circle. So this is very, very important part, the circles we have. Now apart from circles, one of the most important thing we have, that is called parabola. That is called actually parabola. So if we think about parabola, so which is very, very important type of equation for us, that if we think about parabola, so let's have the graphs first, then we'll discuss about it. So this is our, again, very common, the two-dimensional axis, x o x dashed, y o y dash. So if we draw a curve like this, parabola is also an open curve. This is called the vertex. Here the vertex is at origin. So when the vertex is at origin, this type of graph will be denoted as x square equals to 4ay, and if it is bounding towards the y-axis, and if the vertex is same and it is bounding towards the x-axis, this is y square equals to 4ax. And we should remember one thing, that when we think about parabola, we must have one particular idea, that in case of parabolic equation, one side of the one variable must have 1 degree higher power than the other, like x square is there, so there should not be y square, there should be y only. If y square is there, should be x only. So these are the things we must remember from this particular approach. Now from here, again, if we can draw some better equations, like x and y, this is the origin, this is y dashed and this is x dashed. Now suppose the parabola is taking the curvature from this point, this, let it be the vertex, which is at a point minus alpha minus beta. So here the vertex is not at the origin, is on the third quadrant, it is at minus alpha minus beta. So here what will be the equation of the parabola? This will be an equation of the parabola like x plus alpha whole square equals to 4a into y plus beta. So this will be the nature of the equation. So if the particle was here, suppose the particle was here, suppose this is a point alpha beta, then the equation of the parabola, if it was like this, then this parabola will have the equation x minus alpha whole square equals to 4a into y plus beta. Suppose the parabola is going like this, the curvature is bounding towards the x-axis, this parabola will be taken as y plus beta whole square equals to 4a into, so it is actually x, this should be y minus beta, so y minus beta whole square equals to 4a into x minus alpha. Now here also, if the parabola is taking a curvature like this, if the parabola is taking a curvature like this, from here it is towards x-axis, so this equation will be x minus alpha whole square equals to 4a, so it should be x plus y minus beta whole square, y plus beta whole square, because the coordinates are minus alpha minus beta, y plus beta whole square equals to 4a into x plus alpha. It will be like this. So these are the different parabolas we have. And one more thing from here, suppose like we have done, you have done in the class 11 level projectiles. So you know that this type of equations are there with respect to origin, and this type of equations are often represented by ax plus bx square. It is also a parabola we have. So this kind of equations we know, if this parabola was like this, so it would have been x equals to ay plus by square. So these are the basic parabolic equations we have in our syllabus. And apart from this, we have ellipse, hyperbola and rectangular hyperbola. And rectangular hyperbola is one of the most important type of conic graphs used in physics. Now if we think about ellipse, It is so important for us actually that ellipse is the basic, and we all know the circle is a special case of ellipse. So ellipse don't have any center. It is symmetrical with respect to origin most of the times that we have. So let's consider the ellipse first, and it doesn't have center, it has two foci or plural number of focus. So this is the ellipse, and this is one focus and this is another. And this is the difference between ellipse and circle is the point, the central point to the central to circumference, the distance was constant for circle. It will not be true. We know this is called this is one focus and this is another. So this is, we know this is called the semi-minor axis 2B, minor axis 2B. So this is 2A. So this part is A only and this part is B. So actually if we draw a regular equation, so it is x square by a square plus y square by b square equals to 1. So this is the standard equation of ellipse. So this is the standard equation of ellipse, and somehow if a equals to b equals to r, somehow this a and b gets equal, this equation will become x square plus y square equals to r square, which is basically a circle. So if the semi-major axis and semi-minor axis of an ellipse gets equal, that will be converted into a circle. So it will look like this. So we have already discussed the circle is a special case of ellipse. Now if we think about hyperbola, the same, that those semi-major and semi-minor axis, and this is least required in your NEET syllabus, but we still need to know about this equation, x square minus y by a square minus y square by b square equals to 1. And if we draw this graph, so this can be an equation like this for rectangular, for hyperbola only. Now the important thing is we need to know about rectangular hyperbola, one of the most important case which is required in physics. That suppose this is xy and this is x-axis and y-axis with respect to the origin, and if there is a relation between y and x, that y is inversely proportional to x. That means if x is increasing, y is decreasing. So that surely means xy equals to constant. Just for an example, Boyle's law, where at constant temperature pressure of the ideal gas is inversely proportional to volume. So that time we can write obviously PV equal to constant, and I know you have drawn it several times that these graphs will be like this. So here also if y increases, x decreases. This graph is known as rectangular hyperbola. So wherever in physics there will be an inversely proportional relation, there we must take this equation, must take this ultimately this graph. So this is very, very important for us. Now from here the basic graph natures all we have discussed. So from here we will go towards the natural applications of all the graphs we are going for in NEET purposes, competitive exam purposes. The graph we will be looking forward. Now we remember that in any xy graph, the slope is given by tan theta, which is actually what? Which is the rate of change of y with respect to x, that is dy dx even you can write. So suppose you have a graph which is denoting st, displacement time. So in this graph, if we have a straight line, and obviously it has tan theta, so tan theta will give me the rate of change of s with respect to time. So this tan theta will definitely become velocity or the speed. If the s is displacement, tan theta will be velocity. If s is what s is called, that if the s is distance, that tan theta will be speed. Again, if we have a velocity time graph and again this theta is there, then this tan theta will be del v by del t, so it should be acceleration. So remember one thing, students, very carefully. For a VT graph, we know we have done it in class 11. For a VT graph, if we find out the total area under this, that will be the distance or the displacement. And if it's an acceleration time graph, if we find the total area under it, we'll get the velocity or the speed. So this we got theoretically in class 11 standard, and we don't need to repeat this because we want to have its application in our detailed operation over here. Now this tan theta del S by del T, tan theta is del V by del T, it is so important for us. Now from here, from this particular approach, we are going towards a very, very important discussion, that is that we got tan theta, that we got this, that, so much, this many things. But here we are going towards the detailed application of all this. Suppose I am starting with a very simple problem, that a particle starting from rest, it is moving with uniform acceleration. So starting from rest, a particle starting from rest, it is moving with uniform acceleration. So acceleration A is constant. Starting from rest means initial velocity is 0. You are asked to draw is VT graph, number 1. You are asked to draw is displacement time graph, number 2. You are asked to draw is velocity displacement graph. So these are actually the three things they can ask you from this particular situation, which is so normal to us. The starting from rest means u is 0, and the displacement, if it is s, and the velocity is v after a time t. So we know v equals to u plus at and s equals to ut plus half at square, because it is moving with constant acceleration, not the retardation. So here if we put this condition, so v will be at and s will be half at square. So this is the relation between VT graph, this is for ST graph, and if we write v square equals to u square plus 2as, so it will become v square equal to 2as. So this is for VS graph. So if we draw the VT graph over here, so VT, this is the origin, and this is v equals to at, a is a constant. So it is a simple y equal to mx graph, where you can draw this. This is a y equals to mx1. Now if I draw the ST graph here, S versus T, this is the origin, S we got half at square. So t square equals to 2 by a into s. This is a constant which is identical to x square equals to 4ay, that is a parabola. So it should be like this. So x square equals to 4ay, there is a parabola, and this parabola should go like this. Again, if we draw VS graph with respect to origin, so V is taken as y-axis, S is taken as x-axis. So we know that equation v square equals to 2as, we have recently taken this 2a as a constant. We can take y square equal to 4ax. 4a and 2a, they are behaving like constants, and y square equal to 4ax is again parabola bounding towards the x-axis. So these will be the natures of this VT, ST and VS graph for this particular graphical approach, what we have started to do. Now from this beginning actually, what we are actually entering into the new world of this calculation. Let's have one particular type of problem which is so familiar in ever we have seen in different competitive exams. And suppose it is like this, an ST graph, and this is the origin. This A and B, there are 2 points we can have. If this angle is 30 degree and this angle is 60 degree. So we need to find out the ratio of velocity of the particle at points A and B. Of two particles at points A and B, we need to find out the velocity ratio of a particle at points A and B, or two particles which are moving at point A and point B. Now from here, one thing we already know, we have already discussed that any graph like XY graph, VT graph, there should be a slope of the graph. If there is a slope of the graph, so definitely we have that concept. The slope of the graph is what? Tan theta. Now in a ST graph, from this ST graph, this slope tan theta will represent you the velocity. So V at A, it is definitely tan 30 degree, and V at B, it has to be tan 60 degree. So tan 30 degree is 1 by root 3, tan 60 degree is root 3. So if I take their ratio VA is to VB, 1 by root 3 is to root 3. So root 3 if I multiply equals to 1 is to 3. So this is the standard answer for this particular questions that we have faced here. So we need to concentrate on this particular idea that ST graph slope is velocity, VT graph slope is acceleration, and VT graph's area is called distance, and acceleration time graph's area is called velocity. So these are the important things we are concentrating on. So very, very important discussion we are into. Now we are going towards another problem related to this. Suppose again I have drawn a ST graph. I am showing 2 points like similarly. Here let it be A is 45 degree and B which is 60 degree, and the particle has traveled from A to B within a time 2 seconds, and you are supposed to find out the acceleration of this moving particle. And how we can find out the acceleration of this moving particle? See, we all know there is a formula for acceleration which is final velocity minus initial velocity by time. Here the final velocity is VB, initial velocity is VA by time actually. Now here, so we have already discussed, I have separated these two problems, that at A it should be tan 45 degree here, and definitely at B it's 60 degree. So definitely what we can write, tan 60 degree is root 3, tan 45 degree is 1 by 2, and how much it will be? 1.732 by 2. It is 0.732 by 2. It is 0.366 if it is given as meter or something like this is meter or this is second is obviously. So it can be 0.366 meter per second. So this will be a standard numericals where you can have the velocity and displacement, then how related to the graph that we can actually do. So from here we are moving towards our next problem, and hopefully it is clear to you all. It's very simple and very easy to start with. Suppose I am giving you a situation like, suppose a cricketer is throwing a cricket ball upwards against gravity, and definitely it is reaching to the greatest height and again coming back to that fielder's hand or that cricketer's hand or to the ground, whatever. So if you are asked that what should be the velocity time graph of this particular cricket ball when it is thrown vertically upwards against gravity, so naturally it comes to our mind that it is definitely its velocity is decreasing when it is reaching to a particular height, that is called the greatest height we know, and at the greatest height its velocity will be momentarily 0, and again it will come back towards the earth and its velocity will be increasing. So naturally a thing comes to our mind that its velocity's nature, the graph nature will be like this, decreasing, becoming 0. Here it becoming 0 momentarily and it's again increasing. But velocity is a vector quantity here. So we have to consider that how velocity is changing. So if the velocity is changing here, so velocity decreased to 0, again it is changing, but the direction of the cricket ball is changed from the greatest height, it is coming down to earth. So here the velocity is increasing but against the direction. So we have to take the velocity increment but in the negative quadrant. So these kind of graphs are always important for us. Okay. So this kind of graphs can be given. Suppose one thing is given, a train is moving on a horizontal track with uniform velocity. Let that velocity is u. A train is moving horizontal velocity along this x-axis. Now a passenger inside the train drops a coin through the window outside the train at the platform to a beggar or anyone. Okay. Now drops a coin. So obviously when the passenger inside the train, so the passenger speed or the velocity must be identical with the speed of the train, obviously. So when it is happening, actually the passenger inside it dropping the coin. So coin is dropping due to gravity, and gravity is obviously along the y-axis if it is the origin, and this is the acceleration due to gravity. So the coin is getting dropped due to the acceleration due to gravity, but it has the inertia of motion along x-axis at the velocity along x-axis is constant. So it will try, though it is falling down, there will be a tendency of two-way directed motion. One component of this motion should be along the horizontal direction and one should be along the vertical direction. So when it is happening, actually one thing we can notice that at a time t, it should have both displacement towards the horizontal direction and towards the vertical direction also, and let that point is P, where the coordinate is xy. So if this one is y and this one is x, so ultimately here the x is actually traveled by this constant velocity displacement s equals to vt. So x should be ut here, and time you got is actually x by u. Now from y, it is moving under acceleration. So there should be this equation ut plus half at square, and along this direction there was no velocity for the coin, or no velocity of the train, or no velocity of the passenger. So u is 0, so s should be half at square, and from here we can write, here the displacement is y vertically, so y equals to half gt square. So now if I write y equals to half gt square, so y equals to actually what? It is half g. If I put this value of t here, it is x square by u square. So x square equals to 2u square by g into y. So x square equals to 2u square by g into y, and you know very well it is an equation of a parabola which is x square equals to 4ay, where 4a is a constant. So from here, this will be the nature of the curve, and this should be the x square equals to 4ay, and this should be the parabola. So one person who is standing on the platform outside the train will see the coin is getting dropped by the passenger towards the earth surface or the platform or the ground surface at a locus, with a locus, according to a locus, a trajectory of the motion, which is a parabola, which is actually x square equals to 4ay. So naturally this kind of things we can see from this particular incident, that this type of motions things they can be asking about the equation of the motion or the nature of the parabola. They can ask in the various 4 options in the question. Now from here I want to disclose some particular concepts of velocity time graph. Like if I draw a graph like this, for a velocity time graph, if I draw a graph like this, then what is actually meant by this graph? Here with respect to time, the velocity is not actually changing. So when the velocity is invariant with time, it is not changing with time. So velocity should be called constant, or this situation is called uniform velocity, constant or uniform velocity. Now here we draw another graph. So if here this is the nature of the graph, so naturally it is a slope is there, so tan theta is there, and slope of a velocity time graph is acceleration, and the acceleration, the slope of a straight line must be a constant. So it should be called a uniform acceleration. So here acceleration is constant, or you can call it uniform accelerated motion, and obviously it is starting from origin where t equals to 0, v is also 0, so there is no initial velocity. So you have to write that this is the uniform motion, uniformly accelerated motion of a particle started from rest. Now from here, what about this motion at t equals to 0? Definitely there is an initial velocity u which is not equals to 0. So it is also constant acceleration or uniform acceleration. but it has started definitely with some non-zero velocity. So this is very, very important equations which are corresponding these graphs for velocity time. Now suppose if I draw a graph from this particular point, if I draw a graph like this, that what will be the nature of this graph? You can clearly see the velocity is decreasing, and the rate of decrement of velocity is known as retardation, and retardation is also called negative acceleration by the methods of calculus. So we know this is actually uniform retardation. You can say uniform retardation because it is along a straight line, slope will be constant, or you can say uniform negative acceleration. So these are the important facts we have from this particular order. Now again, if I draw the graph again on Vt, this is the origin. Oh, I forgot to write. No issues. So again, so if this is the graph, also velocity is changing as in the decreasing order. So velocity decreasing, so here it is, I should write it is variable or non-uniform retardation. This is called non-uniform retardation. So this is very, very important idea we are sharing with you. So this is very, very important concept that velocity time graphs can show multiple behavior that we can expect, and there can be 3 more cases that we can discuss from here. Suppose it is asked that what will be the nature of increasing acceleration? That means velocity will increase, but in a varying rate, it is increasing rate. So this is actually giving us the graph of increasing acceleration. Then similarly, again if we plot a velocity time graph, and if the graph is showing a curve nature like this, this is called decreasing acceleration. So these are the graphs we are drawing on velocity time approach, and this is going to be a very, very important issue that we are discussing over here. So in velocity time graph, if they ask you that what will be the nature of the infinite acceleration, what will be the nature of infinite acceleration in a velocity time graph, then how we can express it? That is a very important question for all of us, that in a velocity time graph, if it is the origin, we know that acceleration in a velocity time graph is the slope. Now slope can either be represented by tan theta, or even it can be represented in this graph as dv dt or del v by del t. Now if acceleration is infinite, that ultimately means that tan theta is infinity. So the intersecting angle with the straight line or any curve that with respect to the x-axis is 90 degree. So if we draw at any point, if we draw perpendicular where the theta becomes 90 degree, so infinite acceleration we can have. So this kind of graph you can draw for infinite acceleration actually. So these are the different formats of the graph we can obtain from the velocity time graph nature for a moving particle which is moving with acceleration, retardation, variable acceleration, constant acceleration, whatever be the nature of the path, we can do it like this. Now from here, suppose they are asking us that locus of a moving particle, which is very, very important for everyone, that suppose it is given that x square equals to t plus 4, one equation is there, x square or x equals to t plus 4, suppose it is x equals to t plus 4, and y equal to t square minus 2, y equals to t square minus 2 if x and y are coordinates of a point on the xy plane. So what will be the locus or the trajectory of this particular particle, moving particle? So how we can solve it actually? See very carefully, x is t plus 4. So if I represent the value here by x, so it will be simply t, you can write it like t square plus 4, and t can be written as what? T is x minus 4. So if t is x minus 4, t square will be x minus 4 whole square minus 2. So it is x square minus 8x plus 16 minus 2 is y. So y should be x square minus 8x plus 14. Now it's one side is x square, the other side is y. So it is going to be a parabolic locus. Definitely, we discussed earlier that if one side of the equation is carrying one power of x which is different with the other power of y, that means if x is taken as square and y is a single power, or vice versa, y is in square and x is in single power, then this equation must be referred as a parabola. So this has to be a parabolic locus. We all know about this. So this kind of equations are very common to all, but this type of equations, this type of problems we face anytime regarding the competitive exams. Now from here we are going towards the next type of problem, which is very easy. Once again I am giving, suppose on a xy plane, so on a xy plane definitely the position vector will only carry I and j, nothing else. I and j it will carry, and on a xy plane, suppose it is given like t square minus 1 I cap plus 2t j cap. This is the position vector at any time t on xy plane. It is given in the question. So we need to find out what will be the locus or trajectory of this moving particle. So we can compare this with xi cap plus yj cap in xy plane. So x becomes t square minus 1 and y becomes 2t. So t is actually y by 2, which I can put it here. So x will become y square by 4 minus 1. So y square equal to 4 into x plus 1, which is again a parabolic locus we are getting. So here also it is established, as there can be some different forms of equation we can have, but ultimately it is ending up with some of the curvature we know, whatever we have studied already. So these are the things that are very, very important for us, and we must concentrate on this type of natures very well. Now from here, again a problem I am going to refer, that suppose on an xy plane, it is given as the position vector of a moving particle at any instant of time t is given like this. You have to find out the locus again. So here also we have x equals to at square, y equals to 2at. I have to eliminate t if we want to obtain the relation between x and y. So t must be y by 2a. If I put it here, x equal to a into y square by 4a square. So no options left. It is a simple direct equation of a y-axis bounding parabola. So it is bounding towards the x-axis. So this nature have to be like this. So if I draw the x and y graph, so this has to be again a simple parabolic locus. So we have studied a lot of equations on parabolic locus. So we must not be partial on parabola, we must not be biased on it. I have to discuss all types of motion we have for different types of the graph, obviously. Now see, from here, there can be any nature of the graph we may follow or may not. But the thing is that we can play with the graphs basically. So when there will be some questions like this is given, suppose the position vector is given as r equals to a cos t I cap plus b sin t j cap. It is like this, or you can write like this. So what is the locus of this particular particle is having? So we must compare the same thing again, that x equals to a cos t and y equals to b sin t. So definitely x by a is cos t and definitely y by b is sin t. So x square by a square plus y square by b square, definitely cos square theta plus sin square theta is 1. So this kind of equation, if it is given, so definitely it is a elliptical path on which the particle is traveling along the elliptical path. So this can be a steady equation for a particle like this. Now again, when we are studying the cases of this kind of particles. So we'll have like, if the equation is x equals to a cos t I cap, or suppose the coordinates now given, x equals to a cos t and y equals to a sin t, it is given like this. So what will be the locus of the particle? If I directly square and add them, that x square plus y square will be a square, cos square t plus sin square t will be 1. So x square plus y square equal to a square. So this will be actually the equation of a circle. So this type of motion is giving us a circle locus, or you can say a circular trajectory, circular locus. So which is simply identical with the equation x square plus y square equals to r square. So this type of equations can be there. We must be holding it very tight, very carefully. Now one question can be like from this side. Suppose that suppose I am giving you one particular situation when the x equals to a cos t and y equals to minus a cos t, minus b cos t. So what will be the locus of these particles moving? So when it is moving along any path, we don't know what is that path, and at any time t, these are the coordinates of that particle. So how we can identify them? So here x by a equals to minus y by b. So definitely it is y equals to minus b by a into x. So if we draw a graph, that is x and y with respect to origin, so it's definitely y equal to minus mx graph. So it has to fall down, so it will be definitely a straight line. So these are the things we are organizing. We are actually discussing on these cases when all these probable graphs, whatever we are drawing, it's coming into play in various auctions. Now suppose if one time they have asked you that is this graph at all realistic in nature or not, that a displacement time graph I am plotting, displacement time graph I am plotting here, and if the graph is like this, so at all this graph is realistic or not, I need to explain. So first of all, one thing, a direct explanation I can say that from here the time cannot be decreasing. Time is a variable which always increases, that there is no such thing in this reality, in this realistic world, that time can be reversed. So time cannot be reversed, it can't show any reversal, it always moves in the forward direction. So time cannot be decreasing anywhere under any circumstances. So that means this graph is non-realistic. In any other point of view, if we are concerned with, this is again non-realistic. Suppose we pick one particular time t where a particle can have two positions. How it can be possible that a particle which is moving at a certain time, it is situated on two different positions? If it would have happened, nobody, no policeman, no one could catch a criminal, that he or she would have the alibi that at particular time that particular person was being present at any different place. So at a time, a single moving particle can't acquire two different positions at the same time. So this is very, very important for us, that this type of graphs are actually non-realistic, non-existing in nature. Again, I can ask you one type of graphs problem, that at all these graphs can exist, that if again this type of problem I am asking, that if this graph can exist or not. See here with respect to time, here displacement was changing was time, but then time becomes constant, it's coming back. So how time can be constant? Time is never a constant, it's always a variable. So always time varies, so it cannot be a constant, right? So here also we can say the time is not going to be a constant, and so it is, I am writing as that particular variable, particular displacement. Here this is also a non-realistic graph. So whether it is this or this, these two are non-realistic graphs. So they will be giving 4 options for this, and you have to identify that which one is non-realistic. So one type of question we have discussed from here. Now see from this particular approach, they can ask you a simple type of problem which is also very much important for us. Suppose it's a velocity time graph, and as it's a velocity time graph, it is given as the time is in seconds. So 1 to 6 seconds I am plotting, and here we are having 0 to 2, 4, 6, 8, 10. This is, and velocity is represented in meter per second. So suppose we are having a motion like this. So this is actually the nature of the moving path of the moving particle. Here, however I have drawn, it is parallel to this time axis. So we need to find out the distance over here, and as we know, it's very easy to find out the distance, because in a velocity time graph, area will give us the distance. And how we can find out the distance here? There are two trapeziums and one rectangle. Here is a rectangle, here is one trapezium, and here is another trapezium. So what is the area of this trapezium we can have? It's half into sum of the parallel side into height. So half into sum of the parallel side, that is 4 plus 10 into height is how much? 2. So this is the first trapezium. Then the length into breadth, length is how much? It is 10 into the time interval is 5 minus 2, it is 3. So 10 into 3 plus, so it is 1 second, and this is the height, and this is 10 and this is 2. So it is half into 10 plus 2 into 1. So finally how much it is getting? 14, that is 7. 7 into 2 is 14. So finally plus 30 plus how much it is getting? It's coming as like 12. 12 means 6. So it is 50 meter. So the total distance traveled by this particle along a velocity time graph according to this nature will be 50 meter. So this is a kind of question we can expect anytime from this particular approach. Now from here again I'm giving one question to you. This is again a velocity time graph. Velocity is in meter per second and t is definitely in seconds. And suppose here the velocities are given like the same order I have given in the previous questions. So it's 2, 4, 6, 8, 10. One, 2, 3, 4, 5, 6 seconds are there. So here at the beginning t equals to 0, the velocity was maximum 10 meter per second. Now at 6 second time it is 4 meter per second. It is 4 meter per second. So we need to have the average velocity of this motion, and we need to have the acceleration of this motion. So definitely for this particular problem, whatever we can notice from this diagram given, so this velocity is actually falling with time. So this cannot be acceleration. Yes, it can be negative acceleration, but it is actually retardation. So acceleration will come negative definitely. So if I want to have the acceleration or retardation, whatever, if I can find out that how much angle it is being created with the positive x-axis that is being made here. So we don't need it actually. Here the velocity, maximum velocity is 10, which I can take as u, and the minimum velocity I am getting after a time t, that t is 6 seconds, that v is 4. So actually what I am getting, that velocity is equals to, we know that u minus at, or you can write the acceleration as v minus u by t. So v is how much? Here v is 10, and here you can't write v10 because v is decreasing, u is 10 here, so it's 4 minus 10 by 6. So it is simply minus 6 by 6, so it is minus 1 meter per second square. So you can simply have this equation as the average, the acceleration of the system is negative. So the velocity is decreasing, but you can see it is a nature of y equal to minus mx plus c graph. So it is actually u minus at graph. So it's a linear motion. So if it is a linear motion, then the average velocity, there's a motion along a straight line, so it should be u plus v by 2. So naturally it is 10 plus 4 by 2, it is actually 7 meter per second. You can write it like this. Or there can be another problem, that in total average velocity can be taken as total distance or total displacement by total time. The total displacement is the area of this, and what will be this area? If we find out this area, it will be half into 10 plus 4 into 6. How much it will be? It is 42. This 42 meter is the total distance, and the time taken is 6 seconds. So total distance by total time, it is again coming as 7 meter per second. Now it's up to you that which of these two formats you would like to use to calculate the average velocity and time for this actual purpose. Now from here, so this is a very, very important problem we noticed here. Now from this particular problem, we are going towards another section, like if there is an acceleration time graph. If there is an acceleration time graph and we need to have this kind of approach of this graph, where this is the origin, so time is given in second and acceleration is given as meter per second square. So suppose it is given like 1, 2, 3, 4, 5, 6, it's up to 6 meter. So this acceleration time graph I have drawn, you can see here 0 to 6 seconds it is plotted, and 0 to 5 seconds it is plotted, and the acceleration is showing that 0 to 6, maximum 6, and it is coming as 0 after 5 seconds. So we need to find out that what is the maximum or what is the average velocity. What is the average velocity of this particular moving particle? See, here the velocity is, acceleration is decreasing. Now we know that in a velocity time graph, the total area covered is known as the distance or the displacement. But in an acceleration time graph, the total area covered must be the average velocity, because here the velocity acceleration is decreasing to 0. That means their velocity is also becoming constant. Here the acceleration was maximum, the velocity was also increasing. So here if I can get this area, that will give me the average velocity in this time interval of 0 to 5 seconds. So this is very, very important, that this area will give me the average velocity of this acceleration time graph. So it is half into 5 into 6. So it has to be 15 meter per second. So this type of problem, what we notice from this particular approach, it is 15 meter per second. So here we get that when acceleration is changing with time, it will be changing like this. So this is very, very important type of problem what we have already noticed, and I hope it is clear to you that how these graphs are helping us to find out different types of velocities and acceleration in different cases. Now suppose it is given for one particular problem like this, that velocity time graph, if it is given like this, suppose it is 10 seconds, this is 10 meter per second, and this is 15 meter per second. So this is ultimately, so three particles are starting from same point of view with same initial velocity, and they are moving along these three different directions as it is shown by this velocity time graph. So what we actually need to find out here, that we need to find out the ratio of the distances. We need to find out the ratio of the distances of these three particles have traveled. The particle 1, particle 2 and particle 3, that find out the distances ratio they have taken. So if I think about the distances covered by first particle, so the first particle, particle 1, the entire trapezium is the distance, the entire trapezium. So particle 2, so for the second particle we have, it will be this rectangle. So second particle, it will be the rectangle. For the third particle, it has to be like this right angled triangle. So this entire trapezium for the first, the rectangle for the second, and the right triangle for the third particle. So how we can actually find out the ratio of these distances? So we can write like S1 is to S2 is to S3. So for the trapezium, if we have, that is half into sum of the parallel sides, it is 10 plus 15 into 10 is to S2 means the rectangle, it is actually it will be looking like a square basically. So it is 10 into 10. It's a square, it's there as we have given the same dimension, so it has to be a square. So it's all about my drawing, forget it. So it's S1 is to S2 and S3. What about this S3 here? S3 is a right angle triangle. So it is half into base into height. So if I take this ratio actually, it is 5 into 15. So it is 75 is to 100 is to 50. So this will be the ultimate nature. So if I divide it, the entire ratio by 25, so 3 is to 4 is to 2, this will be the ultimate answer for this particular question. Because here, what we are actually looking for, that the particle when it is traveling, so it must have traveled along the VT graph. When it's showing the VT graph, the velocity time graph's area for different particles will definitely give me the areas, the distances at for three different particles for same time. So these are the actual different graphical notifications, graphical analysis of motion, whatever we have done. If you see the previous year's papers, they are very much important, and every year they set some graphical papers from this particular thing. Suppose one question I'm asking you, there is one balloon, that hot air balloon you have, that hot air balloon you know about, they carry the cargoes, they carry persons in tourist vehicles like this. So this hot air balloon, if it is moving down and suddenly the pilot of the balloon drops some sandbags, then what will happen? The weight of the balloon is decreased and naturally the balloon will uplift. It will move up in the air. So what will happen actually, which is very important to us, that when the balloon is uprising, when actually this balloon is uprising, if they ask you that when the balloon was decreasing, it's definitely an acceleration. When it is uprising, After dropping some sandbags or weights, it is moving with same acceleration. So if they ask you what will be the velocity time graph, then this will be our graph that initially it was dropping due to its weight. So definitely its velocity was increasing due to gravity, but certain time now it is moving up with the same acceleration. That means velocity is not decreasing. So actually what is happening over here, so you will look like that velocity is dropping here. Velocity is, when it is moving up, its velocity will decrease. But remember, due to the sandbag's droppage, it is moving up with the same acceleration. So velocity is not going to be decreased. So this will be the nature of its velocity time graph. If the same question is asked for an acceleration time graph, so what will be the question if it is asked? So for the acceleration time graph, it was moving with a simple acceleration. That acceleration is unchanged but in magnitude, but the direction of that acceleration is reversed. Initially the balloon was falling in the direction of gravity towards the Earth's surface. Now it is changing its direction. So this will be the nature. So this acceleration direction has to be reverted. So students, hopefully you have gone through the entire cases of graphical analysis of motion, and we have successfully completed one of the most important part of our syllabus. After that, according to the chapter breakup, you can see we have vectors and the projectile motions and vertical motions left. Then our big important part of our syllabus, this kinematics, will be completed and will be shifting towards laws of motion. So 3 more lectures you need to have on this kinematics, and then you can say that I have successfully completed the preparation on NEET 2021. It's a big unit, mechanics, 19% weightage, and we have successfully completed this particular graphical analysis of motion in every single year, not even the alternative. In all years corresponding, all representing years, you can see that this type of questions on graphical approach you can't neglect in the exam paper. So hopefully today I am signing out. Keep yourself fit and fine, and in the next class we'll be starting with vectors, resolution and vector addition subtraction. So till then, goodbye, have a very good time, must keep fit and fine yourself, stay healthy.